Hello. So, I'm going to work on the last kind of factoring today, so you can get happy about that. And then the next class will just sort of review all of the factoring, and the following class will start to do a couple different things dealing more with quadratics, like the parabolas that we were talking about. So, this is the last type of factoring. And really, when you go on to your next math class, factoring is one of the most important things to have down. So really try and make sure you understand the basics of these. I'm going to show you how to do factoring by grouping, and then I'm going to show you an alternate way to factor the stuff you learned previously. So I think I mentioned in that video there's a couple different ways you can factor trinomials where a is greater than 1. So grouping is the second way. So we're going to take a look at that as well. All right. So here we go. Factoring by grouping essentially means that you're going to make two groups out of your polynomial, and this polynomial is going to have 4 terms. Okay, so 1, 2, 3, 4. That's the only way we can really get 2 equal groups. So your first step is to make the groups. So we have 21k cubed minus 84k squared plus 15k minus 60. So step 1, group the first 2 terms, just with parentheses, and then the last 2 terms together. And I'm sort of including, I got a little messy there, but I'm including this plus sign with the second group because if it's a minus sign, sometimes you have to think about taking that out as well. Now, once you've made your 2 groups, you're responsible for finding just the greatest common factor. So back to what we did in the very beginning. So 21k to the third minus 84k squared, just focusing on this first piece. Well, what's the greatest common factor between 21 and 84? Well, 21 goes into 84, so 21 we can take out. And then there's k squared and k cubed, so I can take 2 of the k's out. And then if I divide the greatest common factor by both those terms, I'm left with k to the first power, just k, minus 4. All right? Now, when we go do the second group, 15k minus 60, same process, but totally ignore what you did in the first group. We're just going to focus on these 2 numbers. So 15k minus 60, 15 goes into 60, so 15 is going to be my GCF, and positive 15, all right? So if I divide both of those by positive 15, I'm going to get k minus 4. So take a second and look at what we just ended up with, okay? It's not a coincidence that this and this that are in the parentheses is exactly the same, okay? They're both k minus 4. That should happen every single time. So sometimes when you're looking for the second greatest common factor, you want to take out whatever will make this be the same as the first one, okay? And we might have to play with it a little bit, but that's the general idea. And then one more step to finish the factoring to get to your final answer. Well, k minus 4 is common to both of these. So k minus 4, we did this factoring a while ago. You can take that out because it's common to both. And what's left over is 21k squared plus 15. So that's a perfectly acceptable answer. If they said factor completely, then when I look at that, I also see 21 and 15. They have a common factor of 3. So I could take out the 3 and be left with 7k squared plus 5. And if I rewrote that, we usually want the number, just the single number in front. So 3 times k minus 4 times 7k squared plus 5. That would be my final answer. Okay, that would be completely factored. So just to recap, step 1, make 2 groups. Step 2, look for a greatest common factor and take that out. And then step 3, factor by greatest common factor one more time. with whatever's in parentheses. Okay, so what's in the parentheses, that goes out front. What's left over goes next to it. Okay, let's try another one. This one I made a little bit more advanced so we can see what to do. So again, first step, make your two groups. So I'm going to group the first two things and the last two things. There are some occasions where you have to swap out some terms, but I'm going to give you all problems that are already lined up for us, so don't worry too much about that. Then look at the first group, 5 and 4. Well, there's nothing that I can take out of those besides 1, so then I'd go to the variables. We have a squared and a squared. Since they both have a squared in common, I can take that out. And z and c, those are not in common. So a squared is the greatest common factor. So if I divide both terms by a squared, I get 5z minus 4c. Then I go to this second group and I do the same thing. So I'm starting with 15 and 12. Well, I know I can take a 3 out of those. X and X, they both have X in common. Z and C, nope. Okay. So 3X is the GCF. So 15XZ, well, 15 divided by 3 is 5. X divided by X cancels, and I'm left with Z. Remember, you want what's in the first factor to be the same as what's in the second factor, so we're off to a good start. And then 12xc, if I divide that by 3x, negative 12 divided by 3 is negative 4. X's cancel, and so I get just a c there. Again, same thing as we had before, so that is perfect. And then we're going to take the greatest common factor one more time. So now the GCF is 5z minus 4c. That's what they both have in common. And because it's in parentheses, it's one group, so I can take it all out. And so I'm left with a squared plus 3x. Those two things don't have anything else in common, so that's all that my answer would be. Okay? Not too bad, right? Let's do one more. So we looked at a method called slide and divide last time, and this is an alternate option for that. So group factoring by grouping is another way to do the slide and divide type factoring. So let's say I give you 6n squared plus 5n minus 6. What we did last time was slide this piece in the beginning, the a term, to the c term and multiply them. And so I'm going to do that here, but I'm not actually going to slide it. I'm just doing the multiplying. So it gives me negative 36, and the middle term is positive 5. So what I'm looking for, just like before, is two numbers that multiply to negative 36 and add to positive 5. Well, 1 and 36, not going to give me 5 when I add them. 2 and 18, nope. 3 and 12, nope. But 4 and 9 have a difference of 5. And if I want a positive 5, then 4 must be negative, okay? So instead of me going n minus 4, n plus 9, we're going to use those numbers in a little bit of a different way, okay? So what we're going to do is bring down the first term, 6n squared. We're going to bring down the last term. So that line got a little aggressive, which is minus 6. And then the middle term plus 5n, we're going to rewrite that as negative 4n plus 9n, okay? So negative 4n plus 9n, if we combine those, we'd get 5n, but I'm splitting them apart so that I have 4 terms, which means I can factor by grouping, okay? So let's go in here, make two groups. 6n squared minus 4n, well, I can take 2 out of those as well as an n. So 6n squared divided by 2n would be 3n. negative 4n divided by 2n is minus 2. 9n negative 6, I can take out a positive 3. If I divide 9n by 3, I get 3n. If I divide negative 6 by 3, I get negative 2. Look at that. Same two factors there. So that's what they have in common. So that's what I'm going to remove is 3n minus 2. And then out front we have 2n plus 3, right? So if you weren't a large fan of slide and divide that we did last time, you can also do this factoring by grouping. If you like that a little bit more, where you're just taking a trinomial and rewriting the middle term so that we actually have 4 terms and can group it, okay? So I would like you to go and try some of your practice problems, and then when you feel confident, take the quiz. I think it's going to be a 2-question quiz.